Welcome dear students and all the viewers. Now in today's video lecture we are going to begin with another program of our microprocessor and microcontroller laboratory, and that too the hardware part or the interfacing part. We have to design and develop an assembly language program to read the status of two 8-bit inputs. Two 8-bit inputs, for example, one 8-bit input will take as X, another 8-bit input will take as Y from the logic controller interface kit. This is my logic controller interface kit. This is the logic controller interface kit, and we have to read X into Y. We have to display. I mean that we need to display X into Y on this logic controller interface. So this is the program we are going to implement on the hardware. Previous video also I have shown that before performing the interfacing programs execution, what we have to do is we have to make some necessary hardware connections. Those hardware connections is this is of course a kit. Now you all are familiar. In my previous video I have shown you the logic controller interface kit. Okay, then this is the power supply. We need a battery, external power source. As usual we need plus 5 volt and COM here. Okay, we need to supply to this logic controller kit. So you can see that from here I need blue wire and black wire, and these red and green are left unused. This we don't want. Okay, so what I will do is I will connect this blue wire to plus 5 volt. Very smoothly I will connect. Blue wire I will connect to plus 5 volt, and black wire I will connect to the COM or the ground. So I have connected. Then this other end should be connected to the logic controller interface kit. This is the other end. I will connect it. Now you can see here. This is the required hardware connections I have made. Apart from that, this you can see that this is a flat ribbon cable or the FRC cable. We need to connect to the kit, logic controller kit. From the processor, from the CPU's processor, we need to connect to the kit. All the necessary hardware connections. Next we'll proceed with the steps. The following steps: go to start, then run. Now we can type here command prompt or simply CMD, then click on OK. So here I will type cd/enter. Then my MASM folder is in D drive. My MASM software is in D drive in a folder named test. So first what I will do is I will go to D drive, that is D:, enter, then cd test, enter. Next I need an editor window. In order to type the program I need an editor window, so I will give the command as edit program name. My program name is a relevant program name I will give, since I need to take two 8-bit numbers, two 8-bit inputs, that is X and Y. So I will take as program name as xy.asm. Now once I press enter I will get the blue screen where I have to type the required program. The program over here. Now I have to save the program. Alt F. I will save it. MASM. Program name I have taken as xy.asm, terminated by semicolon, enter. So you can see that there are no warning errors and no severe errors. It means that our program is error free. So the next step is link program name xy.obj, terminated by semicolon, enter. So now you can see that I will on the power supply here. The next step is allow IO, followed by the base address. The base address here is 0xe100. The base address is 0xe100. I will press enter, followed by, just we have to give here our program name. My program name is xy, and I will press enter. See what's being asked here. we need to set the data at port B and enter. I need to first set the data at port B. You can see here, this is the port B. This is port B, which is nothing but an input port. You can see here, first input, using the small buttons I will give. X number I will give as 3 first. So here you can see that small white buttons are provided here for giving the input. I will push forward the first button. Here you can see that one LED is glowing. Then since I am giving 3 number, one more white button I will push forward, the second white button. So one more LED has glowed now. Now you can see that one important thing. If an LED is glowing, it indicates 1. If LED is not glowing, it indicates 0. Here X is equal to 0 0 0 0 0 0 1 1. Okay, this is the higher nibble, this is the lower nibble. You can see that in binary it is 0, it is 3. So the first number I have given as 3. 3 is my first 8-bit number I have given, so I will write here X is 0 3. Now the next number which I am going to give, the second input is Y, and I will give it as 2. In order to give that, you can see here, I will write it 0 0 0 0 0 0 1 0. This will be what? This will be my 2. So this is what? This is my 2. Now you can see here, the second input I will give here. I will enter. Already I have given the first input as 3. I will press enter. Now it's asked to give the second input. So second input is just 2 I am giving. So here you can see that one LED is glowing. It means that here these LEDs are off. Port B I am showing input port 0 0 0 0. 4 LEDs off. It is the upper nibble 0. Then 0 0 1 0. It is 2. Lower nibble is 2. So as I have shown here, Y input is 2. X input is 0 3. Y input is 0 2. These are 8-bit numbers. So if I multiply them, the output is 6. So I will show you here on the logic controller interface kit. Just I am pressing enter. Now upper order result at port A. Upper order result at port A. So 0 6 I should get. Actually this LED is actually glowing. It should not glow due to some loose connection here. It is showing. So actually it is 0 0 0 0 0 is 0, and lower order nibble we should get as 6. Here you can see that last 4 LEDs I am showing 1 2 3 4. In it I should get 6. It means that this and this LED should glow. I will press enter one more time. You can see here lower order result at port A. Now you see here lower order result I am showing 0 1 1 0. So X into Y, that is 0 3 into 0 2 should fetch you 0 6. So same thing is there. In the upper nibble you should get 0, in the lower nibble you should get 6. So here you can see that, as I have said that this LED is glowing, it should not glow. So 0 0 0 0, it should be 0, but due to some loose connections here it is glowing 0, and this is 6 0 1 1 0. So this result we got perfectly. So this completes the output. Here we have multiplied two 8-bit numbers X and Y, and we got the result on the logic controller interface kit. I hope this output is clear for you all. Thank you.